For exam, for the beginning of chapter 9 and chapter 9.1 and 9.2, you need to know 2 formulas. That's good enough. Since x is a function of t, so f of t, and y is a function of t, maybe different, maybe the same, g of t. Then formula number 1, what is derivative? dy over dx. Take carefully derivative of the y separately, like so. Did we record? Yes. Yeah. And separately, not with respect to x, that's actually pretty important, with respect to t. And separately, take derivative of x with respect to t. So let me highlight that. With respect to t, like so. That is important, so it's a new formula now. That's what we should practice, and that's what I put on a test. Just random function, find a derivative. And the other formula, if, is arc length. Only 2 formulas to remember. Arc length L, we practiced it last time. Integral from a to b, a gigantic, like some students said, square root, derivative squared plus derivative squared. Because now we have 2 derivatives with respect to t, but derivative of x and derivative of y, derivative of run and derivative of rise separately. So arc length, which is the length of the curve, arc length, will have its own derivative. Thus, if there's an exam question or homework question asking you to find dy over dx if the function is represented if the curve is represented in parametrics, parametric form, that's how it's called. X is t to the 4 minus t minus 3, and y is 3 ln t minus t squared plus 3. Now I'm gonna ask people at the back, so like you guys should tell me. Then what is solution? dy over dx. So originally in calculus 1 we told you, oh, you know, we don't really mind if you write it down as y prime or f prime. Well, now it matters, because y prime can be dy over dx or dy over dt. So now, from now on, actually explaining which derivative you're taking is important. I'm first taking the derivative in different colors, you can see, just to show you dy with respect to t separately. So my goal is to carefully put the correct function at the top. Which function goes to the top? Function number 1 or function number 2? 2. And that's the biggest mistake on the test, is to put the wrong one. You look at the second one first. People at the back, do you want to tell me the derivative of dy of y with respect to t? Anyone at the back? Yes, go. Yes, go. You know. I can see it in your eyes. You know it. 3 over t, because derivative of log is 1 over t. Amazing. Minus 2t plus 0. Thank you. You see, so that's what I wanted to do on the test. How about this denominator is derivative of x with respect to t? We're using formula number 1. Anyone over here at the very end, people? What is derivative of x with respect to t? Just like yell loudly. Anyone? You want to say? I can see you don't. No? 4t to the third, perfect. Minus 1, amazing. So that's what I want you to see. See this? What is the correct answer? Not the one when it's half 4t cubed minus 1. That is not correct, because x should go to the denominator. So the other one, boom. You just like solved several problems on the test, and it is correct. The question is, do I need to simplify? Not really, unless we told you, and nobody cares, to be honest. So that's the answer. Now, 2.
I got a question.
Yes?
Is it more appropriate to say you put dy over dt on top instead of equation 2? Because if you look at the problem,
dy over dt.
Yeah.
Yeah, I don't do equation to equation number 1. That's just to like color code and explain.
Okay.
Thank you. The question was like, should we mark it, right? Should we mark it as 1 and 2?
Yeah.
No, that's just for teaching purposes. I'm color coding, like I'm trying to explain it as carefully as possible, but no, it goes fast. You don't even write any of this extra stuff. You just take the derivative. Yeah. Thank you for asking. And the second question, let's find arc lengths. Arc lengths is somewhere. So it's not infinite, okay? This curve is like whatever, doing stuff. So what kind of arc lengths do we want to find? Let's restrict it for t that belongs to, this notation of the c with a tongue means belongs to, interval, let's say 7 to 100, whatever. We're not gonna actually integrate. So the arc length, either I will ask you to write down the formula or actually integrate. This is how you start. You remember the formula. The formula is integral from a to b, gigantic square root, the one derivative squared plus another derivative squared. And order doesn't matter, and the signs do not matter either, because it's squared. With respect to t, this is the formula. Equals. For our case, it's from 7 to 100. Nothing to calculate. Everything is given. It's amazing. This square root. Derivative, should I write down this slowly, or we can do it? Just derivative squared. So derivative of t to the 4 minus t minus 3. We just did it. It's going to be 4t cubed minus 1, and we're squaring it, plus the other derivative, which is 3 over t minus 2t, and we're squaring it. dt. This is full credit. Like, you got it. Now I just need to ask you if you understand it. Did you understand where it got from? Ask me. This is like a good moment to ask. Do you understand where I got it from? I just took derivative of one and another one. In order doesn't even matter here. But moreover, you do know how to integrate this. We did it at the very beginning of Calculus 2 class. You need to sort it out, distribute, then try to integrate. The square root is a problem. Maybe it's your substitution. Maybe it's trigonometric functions. If nothing works, you do numerical integration. Simpson's rule, for example. So this was x prime squared. But again, so writing down x prime is not intelligent, to be honest. People do not like it. dx over dt squared, and this was dy over dt squared. The beauty of this formula that the order doesn't matter. If you mess up the order, just find it in the list. If it's multiple choice, if it's a free response, then I know what you did. Good job. What do you think about that? Not too bad. Formulas, no questions.